So far, everything we have been doing in here has been based on right triangles, which is great. SOHCAHTOA is a wonderful tool and way to deal with right triangles, but right triangles are not the only triangles in the world that we will see. So we needed another way to deal with other triangles. And today we're going to be learning about the law of sines. The law of sines and law of cosines, which we'll be getting to, is for triangles that are not right. So here is the setup for the law of sines. The sine of A over sine A is equal to sine of B over B and equal to sine of C over C. So when do we use it? You use it if you have a measure of two angles and only one side. Okay? So if you think about that, how many is that? 2 plus 1 is 3. Let's say we were looking at A and B. Then we have 3 out of the 4, and then we can solve for the fourth missing number. Or you have the measure of two sides and one angle opposite one of those sides. Once again, 2 plus 1 is 3, and therefore we can do 3 of the 4 and cross multiply and divide. Okay. So it says solve the following triangles using the law of sines. Draw the triangles and show all work. So angle A is 52 degrees. Angle B is 31 degrees. And A, which is opposite the angle A, is 8. And we're obviously trying to find B, because we have angle B. So again, sine of A over side A equals sine of B over side B. So now we just fill in our numbers. Sine of 52 over 8 equals sine of 31 over B. Now, before we do any algebra, I want you to ask yourself, based on what we've learned way back at the beginning of this unit with 30, 60, 90 triangles. Remember the 30, 60, 90 triangle, the smallest side was opposite the 30. The medium side, or long leg, was opposite the middle or larger angle. And the largest angle, which was the largest side was opposite the hypotenuse, was opposite the 90, which was always going to be the biggest angle, because the other two angles had to be less than 90. So thinking about that relationship, what do we suspect B is going to be? And I don't mean the actual number, just think about it. Is it going to be bigger or smaller than 8? Eight is opposite 52, which is bigger than 31. Therefore, we should expect that side B should be less than 8. So now, all we're going to do is take our calculator, we're going to cross multiply and divide. So B is going to be equal to 8 times the sine of 31 divided by the sine of 52. And if you type it in your calculator just like that, you should get B is equal to rounded 5.23. And we're going to start rounding to the hundreds place. 5.23. Okay, again, just draw a triangle, doesn't have to be great artwork. PQR. Measure of angle P is 13. Measure of angle Q is 133, obviously not drawing scale. And Q is 9. So we're solving for QR right here. Now again, 133 is much bigger than 13. So side QR should be less than 9. So again, sine of 13 over the unknown is equal to the sine of 133 over 9. So P is equal to 9 times the sine of 13 divided by the sine of 133. So while you're taking these notes, it's a good idea to hit pause and actually do this on the calculator and practice the keystrokes. So 9 times sine of 13 divided by the sine of 133. And that's 2.77. Rounded. Which makes sense. Much smaller than 9. Okay, here we go. Again, draw your triangle. R. That's a horrible R. E. That's a horrible E. That's an okay D. Angle R is 47 degrees. Side R, which is over here, is 13. D, which is right here. Oops, what am I doing? That's just silly. It's a lowercase d. D is right here. We're missing the angle here. So again, sine of the angle 47 over its opposite side is equal to sine of D over the length of side D. Of course, I don't know what I'm thinking. We can't have that many unknowns, and we already know what D is. We know that D is 9. So let's fill it in properly. Sorry about that. Okay, so this one is going to have an extra step because remember, we're missing the angle. And what do we always do when we're missing an angle? We have to do the inverse. So we're going to say the sine of that missing angle is equal to 9 times sine of 47 divided by 13. So the first thing we're going to do is just do this part right here and get a decimal. Sine of the unknown angle is 0.506. It goes on, but that's enough. 5063. Okay? Now, going back to what we've already learned, we're just going to solve for the missing angle. At this point, right here, we've already done these problems. We have the decimal, or something's given a fraction. We're trying to find the inverse. So we type our calculator, inverse sine. To find this angle, and we type in inverse sine, 0.5063, we get 30.6